Is my screen share popping up? Perfect. All right, everyone, let's get started. We have a lot of important ground to cover today, so we're just gonna hit the ground running. Today, we're going to be reviewing advanced plotting, which is going to be super, super helpful for all of your final projects, but also just like in general, like plots are kind of the major way that we represent data information because like nobody wants to just look at a raw set of numbers. And we already touched on, I believe, Matplotlib in general. You should know how to make like a line plot and a scatter plot. And I think we briefly touched on subplots, but we'll have a little bit of a review on it today. And then I'll also show you some other fun types of plots, specifically 3D plots and statistical plots using Seaborn. Announcements. Please, please, please submit your final project proposal. Please, because if you do not submit that, we cannot give you feedback, which means you can't really start working on a project. We want to get this feedback to you like ASAP, because the earlier you start, the better it'll be. Less stress, yippee. The earlier it's out of the way, the less you have to worry about this class, bottom line, and you can focus on the rest of your like actual non-decal classes. Homework 7, it is due today, but I recognize that there was a Seaborn question on homework 7, I believe the second question, so we're going to grant you an extension. It'll be posted on Gradescope and on Ed. It'll probably be extended till Thursday, but again, you have the 2-week policy past that date with no like deductions to your grade or whatever. Homework 8 is going to be dropped. And I believe that one's about curve fitting. If you need any help, come to office hours. And like I said, today's lecture is going to be super helpful for question 2. Also, on the B courses, there is a new resource called the Ultimate Plotting Guide. This is like all I use all the time for plotting. It's going to have a bunch of different, like, you could kind of treat it as starter code for like subplots, different types of statistical plots, how to like do fun labels, change markers, all that syntax stuff, all detailed really, really well on there. So please use it because it'll be like super helpful. Cool. So the first thing we're going to do is review how to make subplots because I think we like kind of taught it, but it was like really, really quick at the end of the previous lecture. So what I'm going to have everyone do is open up the advanced plotting demo that I post on B courses, and then make sure you run all the import statements. Please note here, I'm importing a new package called Seaborn. We'll use it later in the lecture, but make sure you do all your imports with all the aliases. Seaborn's alias is typically SNS. All right, so in this first little demo, I'm going to show you guys like I'm going to demo how to do subplots. So right now I have a bunch of random data. I have x, x1, y1, y2, x scatter, y1 scatter, and y2 scatter. We don't really need to worry about this data. This is truly just randomly generated data. This could be anything. It could be like a column from your data frame. It could be like, it literally could be any set of numbers. This is just random sets of numbers. And what I want to do is make a subplot where there is 2 columns and 2 rows. So what I've done for that is define my axes in sets of 2. So I have axis 1 and axis 2, which make up the first row, first 2, like the first column and the second column, and then axis 3 and axis 4, which make up my second row. And I'm saying I want to create subplots 2, 2, and this is my overall figure size. So like the big figure will be 10 by 10. So now, if I want to actually plot onto those figures, I'm going to use like what we learned about plt.subplots. And the way that a subplot works is you can use basically the same thing that you use for like a plt.figure, but instead you have to specify what axis you want to plot it on. So let's say that I want to plot, I'm going to plot x and y1 on my first axis. So my first axis will be the top left corner of my plot. So the way to access it would be axis 1, and you do dot plot, and you do x comma y1, which will plot on axis 1, x and y1. It's always informative to set little titles and labels. Note that it's a little bit different. Usually, remember when we do like a plt.plot, we do like plt.title, plt.x label, plt.y label. For an axis element, the functions are called slightly different names. Again, all this can be found on the internet. Documentation for axis is everywhere. But to set a title, you just do set_title and then dot set, I believe it's set X label, which is going to set my X axis. And ax1 dot set Y label is going to set my Y axis. Cool. Now when I run this, what should happen, sorry, this computer is going to be kind of slow to do all these things, but what should happen is you'll get a plot where you have like a grid of 4 with 2 and 2, and you only have a plot on the first one. Does this make sense to people? We specified axis 1, which is our first row, first column, and we put in x1 and x and y1. Similarly, can someone tell me how we're going to get, let's say I want to plot x scatter and y1 scatter onto the top right. Can someone tell me how we would go about doing that? Yeah, perfect. So instead of doing ax1, we're just going to use ax2. And like you said, we're going to do dot scatter instead because we don't want a line. And my data, it's called x scatter and y1 scatter, I believe. Again, we're going to do x scatter. I'm literally just renaming this. Also, if you can't keep up with like typing pace on this, that's totally okay. I'm literally going to upload exactly what I've typed up here onto Bcourses as soon as lecture is over. I'm going to go through this a little fast because like subplots, once you get it, it's like kind of just copy pasting for every little subplot. But so what this in theory should do is give me in the same row as the first one, a scatter plot that corresponds to the data I put in. Once again, computer's slow, I apologize. Yeah, so now I have a little scatter plot of my data. Notice how I made the silly mistake of not changing any of these labels, and what happened is my label here overwrote. It used to be like X and Y1, so make sure you specify the right axis, otherwise your like labels and stuff will overwrite. Sorry, this should be bottom left and bottom right. That's my bad. Again, now to do the bottom left, you're going to specify axis 3 because that's your second row, first column, and you can input in this one. I wanted to put in X and Y2, so that's exactly what I'm going to do. And then in my bottom right, I want the scatter plot version of this data. So I'm going to literally just do that. Again, I know I'm typing super fast, but hopefully the logic is clear enough that like it can be followed. It's okay if you guys can't type this up at the same pace. You'll have it all. And then that should generate my plot if my Python runs any faster. Sorry, y'all, this is like a super old laptop and it's kind of a hater. But I'm hoping that some of you were able to get something that looks like this. We feeling good about subplots? Lovely. So it's basically the same as a plot, but you can put a bunch of them in one, which is super, super helpful for representation. The ultimate plotting guide, like I said, has great, like, basically what I did for this demo was steal off the ultimate plotting guide. So you'll be able to find, again, all of this stuff that I'm talking about on there. Lovely. Now let's move on to some new things that we actually haven't seen before. Lovely. So this is, again, what we're going to be covering today. First, what is a 3D plot? So, what we've been doing this whole time is basically representing two variables. We've been representing something on the x-axis and something on the y-axis. Sometimes, though, you're going to have things where you want to represent an additional dimension of data. Like, let's say you have x values and y values. You want to represent in the plot like a function of the x and y values. That is one example of why you would want to use a 3D plot. A lot of data that you'll see in the real world, especially image data, will be a 3D plot. For example, if you have latitudes and longitudes and you have a measurement at each one of those latitude and longitudes, that's another example of a 3D plot, right? So you have three data variables that are being represented on one grid versus just two. Does that make sense? You can just think of it as a little map. You can also think of it as like pixels on your, like in an image, because you'll have like a certain coordinate for each pixel, and then you'll have like a color value at each pixel. So images in Python are actually technically represented by these 3D plots, and we'll show you that on Thursday. It's like my favorite demo that we do in the entire class, so very exciting. You guys will make a cool little astro image. But the way that you do 3D plots is first you need to initialize an x-axis, you need to initialize a y-axis, and then you need to create or like tell Python what the function that relates your x and y values are, and that's what's going to show up on your grid here. I'm going to like actually show you guys this instead of just yapping. So this is some new syntax here. I want to call your attention to. np.meshGrid, what that function does is it basically makes a grid. So if you give it a set of x values and then give it a set of y values, it'll literally like, it'll just make a grid with all your x values on the x-axis and all your y values on the y-axis. And then you have something here called np.linspace. np.linspace is very similar to np.arange, if you guys remember that one, or just like the Python range function, where you're able to generate numbers between a start and a stop. In this case, I'm generating numbers between -1 and 1, and I want 100 data points between those numbers. So I'm going to get 100 points between -1 and 1, and that's my x-axis, because I have that as x. And then my y-axis, I want 100 points between -2 and 2. And that's what, yes.
I want to ask, what is the difference between arange and linspace?
I know there is one.
So basically, when you do arange, it's gonna give you, you can even try it out. You can open up the terminal and try it out. But like if you do 0 to 10 and then you do comma 10, it'll give you, or it'll give you like, the third argument is like the number of, it's a step.
Yeah, it's a step.
And
Oh,
then
right.
the linspace is like the third argument is like the number of points between the range.
Yeah, so basically in an np.arange, let's say you have np.arange -1 to 1, comma 2, it'll generate,
It's a step. So
it's a, oh wait,
so do like 1 to 10 and then you do comma 2, it'll give you 1, 3, 5, XYZ. But if you do 1 comma 10 and then you do 2 with linspace, it'll literally give you 1, 5, because that's how many. It's just gonna,
you're gonna get 2 points in that range. Yeah, thank you. But it has a similar structure to arange in that there's a start stop, but instead of a step here, it's a number of points. That's the primary difference. Thanks, Mahan. Okay, so now we've basically, what this has done is initialized a blink grid. So now we have a bunch of x values, a bunch of y values. Now I want to plot the function x plus y. So every single point will be represented, every single point on my grid will basically, the color will represent the sum of x and y. So I'm literally going to do f equals x plus y. And then what I can do is call plt.imshow, and then I can put in my function name, which is f in my case. And then something that you get to do that's really fun is you get to pick like a color map, which basically will tell you like this is a way to like visualize your data. I'll just let it be the default for the first thing, so you guys can see what this does without having to worry about additional parameters. But basically what this has done is it's created a bunch of points like we told it to between -1 and 1. And the reason they're not labeled -1 to 1 is because we have like a linspace. This is just telling us like, this is the 0th point, this is the 20th point, this is the 40th point, so on and so forth for the 100, etc. For the same for the y-axis. And then every single one of these points is the sum of x and y at that value. So here, for example, you have -3, so that just basically means you're probably adding -1 plus -2, and that's what's going on over here. And it slowly becomes positive because as you go from -2 and -1 to 2 and 1, you're gonna get the number 3.
Why is, usually isn't the y-axis 0 on the bottom? Why is it?
Yeah. So, very good note. Basically, MShow does a weird thing where if you don't like specifically define an origin, it will just like, I think it just like arbitrarily defines it kind of funky. But what you can do is manually in your MShow, I believe you say origin equals bottom left. Let me. Okay, yeah. So you can basically say exactly where you want your origin, and then that will fix your like axis orientation. Wait, what did it say? Origin equals lower. And your origin is, like you said, is basically your 0, 0 point. So now it aligns. Does this make sense? Cool. Yeah, for some reason it just like doesn't go by default like low to high on the y-axis. I'm not like entirely sure as to why it does that, but like I said, super easy to make a change. Sometimes though you want your y-axis to run in the other direction, and we'll cover an example of that in the future. But hopefully this like general look at a 3D function makes sense. And like I said, you can also do this thing, which is change the color map. For this one, this is a pretty effective color map because like the colors are very clearly corresponding to integer values. But sometimes like your color maps will be wonky, like the default won't really work because you're like trying to pick out and observe a certain thing. So you can change your color map. And the way you do that, this is something I've looked up like a million times. But you can literally go here to Matplotlib color maps, and they have like tons. So the one that is the default is Viridis, so that's the one we're using. But they have so many that are used. Sometimes you want your 0 values to be white and then your like extremes to be different colors. You can use a diverging for that. If you want a cyclic, basically values that keep being a cycle, you can use one of those. And sometimes you have data that's discrete. You don't have continuous data. So you don't want like those weird mid-range shades. You can use a qualitative color map. And then they just have a bunch that you can use for different things. So yeah, feel free to play around with those. Sometimes if your visualization, you're not like super like happy with it, you can change the color map and like that might bring out certain features that you weren't originally seeing. Here's an example of another color map. It just changes the colors. Okay, cool. So I do want us to take a second to try to work this out in a little group or the people on your table or the people around you. I want you to take a second. You can use the very similar starting code to the plot that I just showed you, but instead make an MShow plot of this function, the square root of x squared plus y squared. And then it says use a mesh grid of 100 linspace values from -5 to 5 for your x and y values and pick a nice color map. So I'll give you guys like 4 to 5 minutes to at least get a starting point on that. Again, the logic will be like super similar to what we just did. But your function is now, instead of x plus y, a little bit more complicated. And again, if there's any questions, just put your hand up. One of us will walk around. Thank you.
Thank you.
Does anyone have any progress, any ideas? Has anyone been able to get a plot? Yeah. Okay, Yippee, do you want to walk me through what you did?
I said x comma y equals p dot mesh grid, and then, and yeah, so that, except for that I changed the
Mhm. Perfect. And then,
and then f equals np dot square root, or x QRT,
Mhm.
x double star 2 y.
play. And then some Python magic happens and you get this guy, I think, is what it should look like. Cool. Fun circle plot. I promise like a lot of this stuff looks a little funky now, but the actual applications of it, you can do like really cool like topography maps, contour maps, all that stuff. Like it's really cool stuff. You can also do like you could literally get images, which is like the most valuable thing to do with this kind of plotting because like you'll have again, like I said, some X data, some Y data, and like each little point on your grid will have a like value, and that might map to like a luminosity, an intensity, or something like that. And then you can actually see like a cool image or a brightness, things like that. Cool. Hopefully that made sense to everyone. I think the next slide just gives you the actual code. This is a different color map. I used hot. This is called bone. Different options. Cool. Are there any questions about 3D plots before we move on? Slide. All right. Next topic. Statistical plots. So what I want to do is take a super quick second. You don't even need to like, if you want to talk about it with people around you, you can. But also you can just shout it out. With people around you, / if you have any ideas. Let's take a quick glance at plot 1. So what this is data about cars, I believe. Like the number of it's data about cars. I don't remember what the data is, but it's a scatter plot of like cylinders versus I think MPG is miles per gallon. So car stuff. Why don't we look at plot 1 and see what's kind of wonky about this representation of the data? If you guys have any ideas, just literally shout it out. Yes. Exactly. So it's a scatter, and it instead of like, it's not really giving you anything super valuable because you just have a bunch of dots in a line. It should probably be like a bar chart or a histogram because you have like discrete numbers on your x-axis and you have continuous variables on your y-axis. So you might want to use a different data representation. Very good. Cool. Let's do the same for plot 2. What's funky about plot 2? What could be what's going on here? This one is a little bit less to do with the actual data and a little bit more to do with like the visualization of the data. Any thoughts? Any ideas? Okay, I'll just give my thoughts and ideas. The big thing that's the issue with this data is it might not be super clear on the projector screen, and for that I am very sorry. But if you look a little bit closely at some of these like very clustered scatter point plots, like you see little groups of them, you can also see that there's likely data being hidden behind certain points. So like you probably have like your data point and then another data point beneath it that might be like the exact same value or slightly different of a value. So what's happening here is you have a lot of hidden data. You can't see all of your data, which sometimes isn't a problem, but sometimes is. So something that you might want to do in a plot like this is change like the opacity of your points so you can see through all your data. That's another example of like things that could be unideal and that packages like Seaborn will help us fix because they have really nice parameters that'll help you do that. So like I said, this was discrete data. not ideal to use a scatter plot. This, I said, hidden data, you have a lot of data that's hiding behind other data. A fix is to make them a little less opaque so you can see a bunch of points. Okay, this is one last plot. There is absolutely nothing wrong with this plot. This is an entirely viable way to display data. What is a way that could be more valuable or an alternative way to represent the data? And I want you guys to think about it specifically in terms of the y-axis. And you can also think about this to the extent, imagine the y-axis had a very, very large range of numbers. For example, in astronomical data, you'll have points that are like very small, but you'll also have things on the orders of mag of like 10 power 10 and 10 power 11. So how would you put that all in one plot? I heard it from somewhere, log. Exactly. So sometimes if you have data that has a very large range of values or like an exponential scaling with a bunch of orders of magnitude of values, you'll want to scale your plots. So you can sometimes, this diagram is like a good cheat as to like if your graph looks like this, how to transform it. You don't need to be super worried about it. It's just like a visual representation. But basically, sometimes you will want to transform the scales on your data. Sometimes you might want to like exponentiate them. You might want to log them. You might want to do something funky with them. You might want to like normalize them, like divide out by the mean. You might want to make them percentages. All things to think about, especially when you have raw data that you're working with, like in your final project. You might just have really wonky plots that don't seem to make sense to you. Like sometimes you'll have like a plot that has a huge y-axis and you'll have like one little point at the top and all your data clustered at the bottom. When you see something like that, that's telling you there's something weird with my scaling. There's like one outlier, like 10 power 10, but most of my data is in this region. And so when you make sure you look at your scale bars, make sure you look at the scaling of your data because it's super, super helpful when it comes to actual representation. Cool. Now we're going to go into actual statistical plots. We're going to use this package called Seaborn. Seaborn is, again, another package that basically builds off Matplotlib, but it allows you to like make a bunch of different types of statistical plots because we've only seen plt.plot, which is like a line plot. We've also seen plt.scatter. There also, I believe, is a bar plot for Matplotlib, but I just think Seaborn does it better, and that's my opinion. You can also do like histograms, box and whisker plot. There's a bunch of plots that Seaborn can do. They can do like contour plots. A lot of fun. And the really, really good thing is it works super, super well with pandas. So that makes our life super easy. So what we're going to do today is look at some examples of how Seaborn can come in handy. This is basically what I was just yapping about. We're going to do it while using the documentation. Like I said, we don't expect you to know all this stuff, but that's what Google's for and that's what documentation is for. So make sure that like you get super comfortable looking at documentation pages because that's really what's going to help you when you're like trying to find certain functions or certain plots for your data. Cool. So the first thing we're going to look at is bar plots and count plots. So Seaborn has a really cool feature where sometimes if you want to just like do visualizations and learn how to do them, they have inbuilt data sets into the package itself. So for the first example, which is a bar chart, we're going to actually use a Seaborn data set. It's called penguins because it's a data set that has a bunch of information about penguins. And I should have I think this is in the demo code, but their function to load up their data set is called load data set. And then you just put in the name of the data set you want to load from their package. In this case, we want to use penguins. And then what that does is it outputs a nice pandas data frame. This is something that we should be familiar with looking at by now, with a bunch of penguin species, where these penguins live, their bill length, the depth of their bills, and some other random details, body mass, and gender. Cool. So in the first question, or the first part of this demo, what I want to do is create a bar plot that has where these penguins live on what island versus their average body mass, which you can see is in the data set. It's given as body mass. So sorry, I'm gonna just like split this into different code cells. And I think the starter code is already provided. So what we're gonna do, plt.figure, and then here, under sns.barplot, can someone tell me if they have any ideas? It's okay if not, what data we would put into this bar plot? Like what would our input be? I suggest to do this, you go onto the Seaborn bar plot documentation and see what parameters it takes in. And once you do that, yell out the first parameter you should input. Exactly, the data frame. In our case, our data frame is called penguins. So we're going to type in penguins. Anyone want to tell me what the next parameter required is? As far as I know, there are 3 required parameters. Yes. X, exactly. So our X data in this case, I said that we want to do the islands where the penguins live. You see that the column name is island, so we can just type in island as a string. And then our last parameter will be our Y, which like I said, is going to be body mass. So we're going to just type in body mass G. Cool. And now when I run this, I should get a nice little bar plot of the average body or the total body mass. Sorry, I think it's total. I don't think, wait, hold up. No, it is in fact average. The average body mass of each penguin that, or not each penguin, of penguins that live on each of these islands. So like I said, super, super simple, like 1 line of code, and you get a really nice looking plot. So that's why we love Seaborn. A lot of built-in features that will help your lives become a lot easier. One of the ones I specifically want to introduce is this parameter called hue. You'll be seeing, I believe you'll be seeing it on your homework, and it's like super helpful. What hue does is it allows you to, again, show, like represent one other variable from your data set. So for example, what I wanted to do here is going to be, again, we're going to take the same baseline plot, but let's say that I want to know how many penguins of each gender are on each of these islands and what their average body mass is. So what I can do here is I'm going to take the same X and Y data, but I also want to additionally split the data based on gender. So I'm going to set the hue parameter to the like respective column in my data frame. And when I do that, what's going to happen is you will now see, I'll just wait till it pops up. Okay, now we have a nice little data frame that not only gives us the penguin home islands and average body mass, but it also separates it out by gender. Does this make sense to people? Yes? No? Are we, any questions? Okay, cool. So that is just one example of what the hue parameter can do. On scatter plots, the hue parameter is very helpful sometimes because you can just pick, like, let's say that you have like a bunch of X and Y data and like you collected the data in a certain way, or there's like another feature you want to represent. You can literally just say hue and give it that data, and it'll give you like a nice little legend with what your like separation of that data is. Super helpful parameter, and we use it all the time. Cool. Now we're going to move on to the next type of plot, which is a count plot. Count plots, again, are very similar to bar plots, but instead of doing like, you see how this like kind of averaged the data? Sometimes you just want like a total count. A great example of this will actually be things that we did with our Titanic data set, if anyone remembers that from the Pandas demo. That is a great way to visualize how count plots are used, because sometimes you just want to know how many passengers were like in a certain condition that you define. So, step 1. Can anyone remind me how to load in a Pandas data frame? Mhm. Perfect. So we're going to do pd.read CSV and then load in my like literal favorite data file of all time. Should be called titanicdata.csv. Hopefully all of you have this downloaded at this point. basically now what I wanted to do, as you can see by the X label and the Y label, I want to figure out how many passengers were a part of each class on the ship. So this ship had first class, second class, and I believe third class. So I want to see how many passengers were in each class. So similarly, if someone wants to, or if y'all want to pull up the if y'all want to pull up the documentation for SNS count plot and tell me what I should put in to get this plot. I will give it like a minute or two. Someone has an answer, just shout it out or raise your hand. Yes. Exactly. So again, we want to put in our data. In my case here, my data frame is called Titanic. So I'm just going to throw in Titanic. And then to put in the passenger class, let me actually display this data frame so we have a better idea of what exactly we want to access. Cool. So what I want to do in this plot is you can kind of hopefully sort of tell by the titles and labels. I want to get how many passengers were in each class. So can someone tell me what the next parameter I would put into my count plot would be? Exactly, P class, because that is the column in my data frame that has information about the passenger class. The way you specify that is saying on my x-axis, I want P class. Do that. I get a nice little count plot. So now instead of having an average of like passengers, because that doesn't really make sense in this context, we want the total number of passengers in each category. So you see that in first class, there's like 200 something, second class, like a little lower than 200, and most people were in third class. Does this make sense? Cool. All right. The last thing I'm going to show you is a little bit of like it's a little bit of like an annoying data type thing that I just want to like make clear because sometimes you'll run. Oh, do you have a question?
Like,
Yes, on of each bar. Yeah. So let's go to SNS count plot. Very, very good question. So we see that there's like a bunch of these optional parameters. So we want to see if there's a way to actually display the value. I'm like 95% sure there is, but I just don't remember what it is. Let's see. I can also just look it up. Oh, so there's not an inbuilt way to do it. That's a little bit annoying. I thought there was an inbuilt way to do it. So I'm gonna go to Stack Overflow and see what people are saying. Cool. Okay, so they're just using like this axis element, which will basically let you put in the counts of the data on the top. So unfortunately for count plots, for some reason, there's no inbuilt way to do this. I like was convinced there were, but Google still gave me a good answer. So I'm gonna literally put that code into my code. Yeah. And instead, we're gonna just run this. And hopefully it doesn't yell at me and it gives me what I want. So there's a way to do it. It's just not on Seaborn. So just Google it. You can copy code off Stack Overflow. That's like fully legal and allowed. That's like what coding basically is. But all this like line of code is saying is like, I'm defining this axis that has the count plot, which we know, the passenger class and Titanic, which is what we just talked about. And then there's this cool thing for an axis called a bar label, which is basically the numbers. And it's just saying that those are contained in the first column, and they want to put the label on the edge of the bar. So that's what this line of code says. And also it's okay if you don't understand what that line of code says. You don't need to. It works. And sometimes that's how it's going to be. Cool. Great question. Good example. Like sometimes you want to do things and you can't find an easy way to do them. But I promise the internet will have a way to do them. All right. So let us move on. So something I want to show you guys is sometimes your data is stored in a different data type that like Python will kind of get mad if you try to like plot it. For example, here it was super easy because the passenger class is stored nicely as like integer values. But sometimes it's going to be like, hey, I don't like the data type of these values. For example, I wanted to do the same kind of thing, but I want to now segregate by survived. So I want to see how many passengers in each class survived. And so the way I would do that, you would think would be very similar, where I have my data, I have my X value. And then here I, like we saw in the previous example, set the hue to my survived column. Oops, that's my bad. Oh. Interesting that worked. That didn't work on my other version of Python. Is anybody getting an error when they run this line? Or is everyone fine? Did this work for everyone? Okay, then we don't have to worry about it. Sometimes though, if your like data has a different data type than the data type that like plot wants, you'll have to convert the data type of that column. And the way you can do that is say that the column name is reassigned to the column as a string. And that should fix your issue. I don't know why it wasn't an issue on this version of my Python and why it was an issue when I was preparing this demo yesterday. Yes.
One of it like switches the order of the survived and unsurvived, the one in zeros.
Mhm.
Is that like arbitrary or
As in like the colors?
like my one's on this?
I don't know if I think it might just be an arbitrary thing, but you might be able to specify it. Yeah. It like doesn't.
But like the data's the same.
Yeah, the data's the same, but I don't know. I'm sure that there's a way to specify the order. I'm just not 100% sure as to what it is. But also like the representation is basically the same. As long as it's consistent, it kind of doesn't really matter. Okay, cool. So this is again another example of how you can use Seaborn and how you can separate. I think the like main thing I'm trying to get across is like visually separating different categories of data and how to do that. And hopefully this has shown you that. And then as a little bonus plot, I wanted to show y'all a little box plot of the ages because sometimes like people sleep on box plots. They are super helpful because it gives you like the mean of the data, the spread of the data, the like interquartile ranges, all of that fun, funky statistical stuff that sometimes is super helpful because you kind of, a lot of times in your data, you'll have like crazy outliers in real data. And you're like, I don't know how much of this data I can keep and what I can toss out. And visualizations like box plots are super helpful because it kind of tells you what data can I keep and what data is it okay if I toss out. And sometimes you really, really need to know information like that. And like pulling up a quick box plot will literally give you your answers. Instead of having to sit out and type out like NP dot mean of the data, NP dot like finding all the quartiles. Like sometimes that's really annoying. You can do it using math, but sometimes you just want a little plot to tell you. And that's what a box plot can do. So I want to make a little box plot of people's ages on the ship. So the way I'm going to do that is I'm pretty sure it's like the same thing where you put in the data and then the X value, but if it's not, it'll yell at me and I can fix it. Each. Nice. So it's telling me like the average age of people aboard the ship was approximately like late 20s. But it kind of has 50% of the people are between 20 and 40, but then you see quite a few data points that are like outliers in the sense of they're outside of the 75th quartile. Yeah, so that's just a good way to visualize how your data is spread. And like I said, Seaborn has like, just looking at this, you can see how many different types of plots it has. Heat maps are super helpful. You can use those for things. They kind of work very similarly to the IM shows we just talked about, but there's a bunch of fun plots. Explore Seaborn, especially for your projects when you're like, hey, I have this data and I want to visualize it in a cool way and I want to show this certain trend or certain relationship. Sometimes you don't want to just curve fit to a line plot. It's super useful, but sometimes you want to do some other fun stuff. And Seaborn is a great way to explore statistics in your data without having to do too much work. Yeah, that kind of wraps it up for lecture today. If you have any questions, feel free to ask. And like I said, we'll host, I believe it'll be an extension on the homework until Thursday, and hopefully this lecture was helpful for that. All right, thanks everyone. Have a lovely rest of your day. Okay.